Hello and welcome to Chapter 21 Homework. So the conceptual question, starting with number 5. The concept is making a short circuit. Don't do it. A student in a physics lab mistakenly wired a light bulb, battery, and switch as shown in the figure. Explain why the bulb is on when the switch is open and off when the switch is closed. Do not try this at home. Alright, so we have a situation here. Here's our light bulb. That's the capital R. Over here, I don't want this to be confusing to you. Usually we just draw the battery symbol, but there's also an internal resistor in the battery. That's the lowercase r. But that's just the battery. So this is our voltage source. This voltage source is connected to a circuit on running right now. Current would run through this bulb and the bulb would light up. When we close the switch, now we have another parallel line. This parallel component of the circuit has no resistor in it. There's no resistance there. I make a fairly big deal about current taking the path of less resistance, but if there's no resistance, all of the current will go that way, and none of it will be driven through this light bulb. So when we close the switch, this light bulb would go off, or be really, really dim, because there's no current running through there. So don't do that. That's just connecting a wire to either side of a battery, and then all of the current would run through that wire, and it would burn out the bulb. All right, so I'm looking for the next question. Strings of holiday lights. So, conceptual question number 8. If we have light bulbs, resistors connected in series, and one of them burns out, that creates an opening in the circuit and current can't run through there, and they all burn out. If we have a special kind of bulb that when it burns out, it just turns into a wire, so that would be a closed switch burnout, then all the other bulbs would stay lit. In situation 1, we have 120 volts and 40 bulbs, so each of those bulbs would get 3 volts. In situation 2, if one of them burned out, and we still have 120 volts, but now we only have 39 bulbs left behind, so that would be 3.08 volts per bulb in that situation. So there you go. Number 17, what are the advantages and disadvantages of connecting batteries in series or batteries in parallel? If you connect batteries in series, like you would do with most flashlights that you would own, you take a 1.5 volt bulb, 1.5 volt battery, another one, another one, you stack them up, we get the sum of all the voltages. So if I have 4 1.5 volt batteries, then I'd have 6 volts total to make my bulb shine brighter or whatever I'm doing. Now that's good, but if one of them burns out, then I'm down to 4.5 volts, so my bulb will get dimmer. So if you've ever picked up a flashlight that's been in a drawer for a while and you turn it on and it's not shining very bright, chances are either all of those batteries are weak and dying, or one of them has died and the others are just kind of hanging on. The other situation, if you set them up in parallel, then you could be running current through a circuit while you pull out one battery and replace it with a fresh one. So if you set up batteries in parallel, it will maintain the voltage because there's a complete path from the circuit load to either end of however many batteries you have. So there would be some advantages to setting up batteries in parallel. There you go. I tried to hit stop and I hit record.